For this circuit we need to find currents IA, IB and voltage V0 here. So what we will do first, these two branches are parallel, this 120 ohms and 80 ohms. These two resistances are in parallel, so voltage drop across them will be equal. So the voltage drop across 20 ohms, which is V0 basically, so 20 times IA from Ohm's law will be equal to 80 times IB, which means IA equals to 4IB. And total current of course is IA plus IB, so total current is 5IB. 5IB will be the total current, which is current flowing here through from the supply. Now since these two resistances are in parallel, when two resistances are in parallel, the equivalent value is, we get from this formula, sorry, Rp is equal to 1 over 20 plus 1 over 80. So that will be the parallel combination, which means Rp equals to 20 times 80 divided by 20 plus 80. This is a formula which we can use directly always when finding finding equivalent value of two parallel resistances. That's what we will do. So that is, if there is R1 and R2, say R1 and R2, that means R1 times R2 divided by R1 plus R2 equals to R equivalent. So these two parallel resistances can be replaced by R equivalent, and this is the formula. So which we have used here, it gives us 16 ohms. So that is the resistance here. This total resistance is 16 ohms, and so the voltage source sees the resistance the voltage source sees is 4 plus 16, sorry, I don't know what I'm doing, so yeah, 4 plus 16 times the current, which is 5IB. So that is R, total R, and this is I, which is I total maybe, and this is the supply voltage Vs. So from that we get 5IB to be 50 divided by 20, which is 2.5. So IB equals to 0.5 and IA becomes 4 of IB, that is 4 times 0.5, which is 2 amps. So this is 0.5 amps, this is 2 amps. We have found the value of IB and IA. We need to find the value of V0, which can be V0 is equal to IA times 20, which is 2 times 20, which is 40 volts, or V0 can be IB times, we will get the same value, IB times 80, which is 0.5 times 80, which is 40 volts, same, or V0 equals to the total current IT times the equivalent resistance, because when it's equivalent resistance the circuit is becoming like this. This is 4 ohms and we have replaced the parallel combination by one resistance, that is 16 ohms, and the same current flows through that parallel branch because IA plus IB is equal to IT. So when we have replaced that, IT will flow through 16, so that will be 16, and IT we know 2.5. So 2.5 times 16, which is 40 volts. So we get the same result. We have to use just one of the formulas and we will get the same result. So yeah, that's what I wanted to show. Now if we needed to find the power dissipated by any of the sources, which we should do, so this is the, what is the power supplied, which is power supplied and power dissipated by each of the sources. So let's find that. So power supplied will be Vs times IT, which is 50 times 2.5, which is 125 watt. Now let's say what is power dissipated by 4 ohms resistance. So we know the voltage drop across the 4 ohm resistance will be, since voltage drop here is 40 and here is 50 volts, so here the voltage drop is 10. So power dissipated by that will be, we could have used I square R, which is okay, or we can use VI, since I know VI, so 10 times I is 16 here, sorry, I is 2.5 here, so that's 25 watt. Then we can again find the power dissipated by the parallel combination. So that will be P I don't know, 16 ohms, let's say. So that will be V naught is 40, and so basically this will be V naught times IT. So V naught times IT, because same total current, we are using this circuit now, which is the equivalent combination. So that will be V naught is 40, and this is IT is 2.5 again, so that is 100 watt. So this is 100 watt plus 25 watt equals to power supplied, which is 125 watt. Or if we needed to find power dissipated by this one and this one separately, we could have done the same thing. We know now what is IA and what is IB, so then it would be P20 ohms would be V naught, which is again the same thing, 40 times now IA, and IA is 2, so that is 80 watt, and P80 ohms would be 40 times 0.5, which is 20 watt. So we can see that 20 watt is dissipated by this resistance, and 80 watts is dissipated by this resistance, and the total power dissipated by the combination of this resistance, basically combination of this part, is, of course, it should be 80 plus 20, 100 watt, and that's what we got here when we use the equivalent resistance formula. We got, where did I get it, this one. So this is basically 100 watt, which is 20 plus 80, 20 divided by 20 watt dissipated by the 80 ohms resistance, and 80 watt dissipated by the 20 ohms resistance.